Today we're going to talk about how to scale area and volume. In other words, if I gave you, say, a rectangle, right? And I told you that, this side over here was 8 meters and this side was 3 meters, right? Now, we understand that the area of a rectangle is just the length times the width, right? So your area is just 3 times 8, which is 24 meters squared, right? Should have no problem with that. If you have a problem with that, go back and watch the old videos. Okay. What we're going to say now is, hey, what happens if we double the length? Okay. Or halve the width. Okay. So these are the types of questions we're going to be talking about. What happens if I double both of them? Okay. And the big thing you have to remember with this is that whether it's area, right, length times width, or say it was volume, right, which is length times width times height, right, or area could also be for a triangle, 1/2 the base times the height, right, or the area of the volume of a prism. Right, we always said that was the area of the base times the height, right? Capital B, right? Or if it was a cone, volume of a cone. Okay, that's my cone. 1/3 pi times radius squared times the height, right? 1/3 the base times the height. Or if it was even a cylinder, right? Volume of the cylinder. Same thing, but it was pi times radius squared times the height. All these different equations that we've been working with have exactly one thing in common, and that's that all it is multiplication. Okay, so if you didn't realize that, there's no addition and subtraction unless you have like a compound shape or things like that, right? Every single operation we've done has been multiplication, right? And even this, yeah, it's you're multiplying by fractions, so you can call it division if you want, whatever, doesn't matter. And one of the things you guys got to remember about multiplication is that it is associative, okay? Meaning we can do it in whatever order we want, right? So let's go back to our original problem here, right? This has an area of 24, right? What if I double the length? Okay, so let's take our original one, which is that our area is equal to 3 times 8, which is 24. So I'm going to say this is the length. Okay, which means I have to switch this around. Doesn't matter, right? It's all multiplication. It's commutative as well. Okay, so if I double my length, right? In other words, I make this 16, right? If I double this side, what's going to happen to this? Well, think about what you just did. All you did was take the area of 2 times the length times the width, right? There's no distribution there. I'm not distributing the 2. All I'm doing is multiplying an extra 2 in there. So what are you going to find is that your area is going to be 2 times 8 times 3, which is 48. So if I double one of my dimensions right here, what have I done? I doubled the area, right? And again, if you wanted to see what that looked like, again, if I doubled this, all I would need to do is, well, I'm going to double this, right? Now that's 16. Then what do? I double the area, right? There's 2 of them now, right? It's terribly drawn, but there's 2 of them, okay? What if I double all of them? Okay, what if I double both sides? So let's do something like a square. Let's do a square, okay? And I said that this is a 4 by 4. So my area is equal to 16, right? Now, what if I doubled both? Well, now think about it. This was length times width, right? Well, what did I say? 2 times the length times 2 times the width. So what did I get this time? I will actually multiply it 4 times my length times my width. So what will you get? 2 times 4 times 2 times 4, right? So my original area was 16. What do I find out? My area is now 2 times 4, which is 8, times 8, which is 64. So what you'll find out is if you double both, you're actually going to do what? You're going to make it 4 times as large. It's going to be 4 times bigger, right? Okay. And again, let's just see, because I have it here, what would that look like? That would look like if let's clone this thing. If I doubled, again, if I doubled the length, right? But then I also double the width, I actually get 4 times as big, right? I double the length and then I double the width, so I get 4 times as big, okay? So just the big idea is you're actually going to square it. So I'm going to do it with a different number real quick so you guys can see. So say, let's do a triangle. Okay, right triangle, nice and easy, right? So it's area of a triangle is equal to 1/2 the base times the height. So right now I'm going to say that my base is 9 and my height is 9. So right now the area of this triangle is 1/2 of 9 times 9. Good job picking an odd number, Matt. Area of a triangle is going to be 9 times 9 is 81. 81 is going to be 40.5, right? What if I doubled? Okay, doubled all dimensions. Okay, again, think about what we just did then. Well, I multiplied this side times 2 and this side times 2. So what's going to happen is it's going to get 4 times as big, right? So my area will actually equal 1/2 of 18 times 18, right? So that means that my area is 9 times 18, which is 90 and 72, 162. That's what you guys got. Okay. Again, what is that? That's 4 times bigger than 40.5. So again, what do I got? I got 40.5 times 4. I get 4 times bigger. Okay. So again, just keep an eye on your formulas and what you're changing the dimensions to. We'll try one with volume. Okay. So say volume, right? And say they gave you this cone, right? I do my best to draw a cone. Not my strongest shape, I assure you guys. Okay? And they gave you the height and they gave you the radius. They said the height was, I don't know, 14 and your radius was 5, right? So again, what's your formula for the volume of the cone? 1/3 pi times the radius squared times the height, right? So what if I said we're going to double the height? Okay, so you gotta think about that. All I'm doing is taking this and my doubled one, equal 1/3 pi times the radius squared times 2 times the height. But again, all I did, look, multiplication, 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 and multiplication. All I'm saying, what happens? I doubled the volume, right? Again, how do you know that? Because I'm allowed to write this. It is associative. I can write it whatever I want. So again, my doubled one, I'm just going to move this 2 up to the front. 2 times 1/3 pi r squared times the height, right? So again, what happened? I just made it twice as big. So again, if you only double one dimension, you're just going to double things, right? What if